Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 12.5, derivatives with logarithmic functions. And there's two rules because depends on if it's a log or a natural log. And your base is a. Remember, when there's no base, it's 10. So we have a log base a of g of x. And we just have the absolute values here because you cannot take the log or natural log of a negative number. But when you're taking the derivative, it's the original function that's on the inside, the natural log of the base. And then in the numerator, it's the derivative of the function. So in the denominator, it's the function and the natural log of the base. And in the numerator, it's the derivative. For the natural log, you just don't have the natural log of a, because the natural log is an exponential function, and we know that the natural log of e is 1. So it's just the function in the denominator and the derivative on the top. Let's try a couple. So if we were going to take the derivative, this one's a natural log. So you put the function in the denominator and the derivative on top. 8x, the derivative of this is 8. Equals 1 over x. Try another one. What you're taking the natural log of, 8 minus 3x, goes in the denominator, and then the derivative on the top, 8 is 0. This gives us negative 3. We cannot reduce because it would need to go into all three terms. This one we need to rewrite it first. And then if you remember your natural log rules, when you have an exponent, you can bring it in front. So we're taking the derivative of this. So we have the 1/2. Move that out front. Since it's a number, we just carry it along. The denominator is x plus 3, and the derivative of the bottom is just 1. So we have 1 over 2 times x plus 3. This one is a product rule. So we have the first times the derivative of the second. Derivative of this one is 3x plus 2 in the denominator and 3 in the numerator, because that's the derivative of the bottom, plus the second times the derivative of the first, and the derivative of negative 5x is just a negative 5. And you don't need to simplify. Now this 4 needs a chain rule. It cannot be brought down because it's on the outside of the natural log. This one was on the inside because it was the natural log of all of this. So you can bring it in front. This one you cannot. You have to use the chain rule. Derivative of the outside . So that would be the outside times the derivative of the inside, x plus 1 over 1. Okay, let's try some logs. I think I have logs next. Oh no, I have one more quotient rule first. So bottom times the derivative of the top. Derivative of e to the x is e to the x times the derivative of the exponent, and the natural log of e is also 1. bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of natural log of x is x in the denominator, and the derivative of that in the numerator, so it's 1 over x. All over the bottom squared. Okay, logs. Now remember, when there's no base, it's a 10. So 6x natural log of the base over the derivative of the 6x, which is 6. These 6's can cancel because there's one term on top and bottom. So it's 1 over x natural log of 10. I would not take off if you left it, though. Now this is only on here. It's not around the whole log, so the 3/2 can come down. Because then we can just carry that 3/2 along because it's only a number. So when we take the derivative, we have 3/2 on the outside. Then the natural log, or the log base 3 is what you're taking the log of, x squared plus 2x times the natural log of the base, and then on the top is the derivative, 2x plus 2. So we take the derivative of this. And you can stop there. One more. So this one, the inside, 3 minus x times the natural log of 5 over the derivative of what was in the side, which is just a -1. And this one is quotient rule, bottom times the derivative of the top. Derivative of the natural log is 6x in the denominator, derivative of that is 6. Minus the top times the derivative of the bottom. So it would be 5x natural log of the base, which is 10, over derivative of the 5x, which is 5. And then you can stop there. So this section's definitely more difficult than the other ones, and we haven't probably used logs a lot, but 12.5.